Hey, so in our last video, we looked at Handout 6D, and I introduced you to bone ossification, the creation of bone. Remember, there were two processes, intramembranous ossification and endochondral ossification. And so in this video, I want to give you some more details about endochondral ossification and take you through the steps of how that works. So let's look at Handout 3E, and I'm going to put it up here on my doc cam. Now, Handout 6E is going to take us kind of through a step-by-step process of how bone is created in a fetus through this endochondral ossification. And remember, most of the bones of our body are made this way. And I'm going to kind of slide this up. And this handout is a series of pictures, right, with different steps. And the first step is having this mesenchyme or mesoderm template. And so it says chondrocytes at the center of the growing cartilage model enlarge. So what happens is we get kind of a template of mesoderm cells or mesenchyme that lays down this connective tissue. And this connective tissue is then slowly replaced by cartilage. Now, this cartilage is going to grow and enlarge the structure. Now, over time, as this cartilage enlarges, the cartilage will be slowly replaced by bone. This is why it's called endochondral ossification. So what happens is we get all of this blue area is the cartilage. So you can see most of this skeleton is cartilage at this point, but we start getting the development of osteocytes on the edge. And so I denoted that with this orange color. So it says newly derived or newly created osteoblasts cover the shaft of the cartilage and form a thin layer of bone tissue. All right, so this cartilage has replaced this mesoderm, this connective tissue covering, and then we get bone cells, osteoblasts, coming in and covering the shaft of the cartilage. Now, this is just going to progress. What happens is this skeleton begins to create blood vessels. And these blood vessels are going to flow into the shaft, into that medullary cavity of the cartilage. And the blood vessels are going to bring in more osteoblasts. So we have the development of bone on the shaft, on the outer edges of the shaft, but then we also have bone developing inside as these blood vessels carry the bone cells into the cartilage model. Now, this area is going to form the shaft of the bone, that diaphysis. And inside that diaphysis, we're going to form that medullary cavity that's got the bone marrow. This growth of bone within the cartilage is called the primary ossification center. And so bone is going to start to develop from the inside out. And as this bone develops, it's going to push the cartilage towards the edge of this structure. And this is just going to progress. So in the next picture, we just have the progression of this primary ossification center. And the bone is going to just continue to replace the cartilage. And the cartilage is going to get pushed out of the diaphysis, out of the shaft, and towards the epiphyses of the bone. So, you could think of this as a femur or a humerus or an ulna. And the bone has completely replaced the cartilage in the diaphysis, and it's pushed that cartilage into the epiphyses of this structure. Now, further development is going to take place, and we get bone also developing in these epiphyses. So bone tissue starts to develop in the center of the epiphyses, and this is known as the secondary ossification center. So this cartilage is further pushed to the edges. So by the time this bone is fully developed, it has started off as cartilage, and then bone has replaced it in the diaphysis through the primary ossification center, and then most of the epiphyses are going to replace its cartilage with bone until we've got just a thin layer of cartilage towards the edge, and then in between the primary and secondary ossification center, we also have a strip of cartilage. This cartilage is called the epiphyseal plate. And your epiphyseal plate is commonly called your growth plate. So we end up with these two growth plates, one on the proximal end of the bone and then one on the distal end. The epiphyseal plates or growth plates are separating the primary ossification center from the secondary ossification center. Now, as we look at this, a couple of things to keep in mind. And I'm going to kind of zoom out here to show you. First of all, bone tissue does not grow in length. It only grows in width. So our bone is actually getting wider because of the bone tissue. But the bone tissue cannot make this structure grow longer. It's the cartilage that grows the bone longer. So that's why our epiphyseal plates, these growth plates, still have cartilage. All right? So this cartilage becomes our growth plate, the epiphyseal plates or growth plates. So our cartilage is going to grow in length and width. So it can make this skeleton wider and longer. But in endochondral ossification, our bone is replacing the cartilage. And you can see how we start off with this cartilage template that is then replaced by bone as the fetus develops. So this is endochondral ossification. Now, actually the next handout 6F, is really just a continuation of handout 6E, and we're going to get to it in the next video. So make sure you just continue into handout video 6F, and I'll further explain this epiphyseal plate or growth plate.